In this video, we're going to look at different ways of solving systems of equations, and specifically how to choose which method to use when confronted with a system of equations. So this first example, it says, look at the system of equations below. Which method would you use to find its solution? And in this example, both equations are in slope-intercept, or y equals mx plus b form. So when you have two equations that are both already in slope-intercept form, the best way to find their solution is going to be graph the two equations, graph the two lines, and then find their intersection point. So we're going to use graphing to solve this one. Both equations are in slope-intercept form. If we graph the two lines, their intersection point will be the solution. And we're going to use a cool website called desmos.com to graph these two lines. So our first line is y equals 2/3 x plus 5. And our second line is y equals negative 2x minus 11. And if I go over here to the graph, I see the red line is y equals 2/3 x plus 5. It has a y-intercept of 5. The blue line is y equals negative 2x minus 11. It has a y-intercept down here of negative 11 and a slope of negative 2. And here's their intersection point, negative 6, 1. So that is the solution to this system of equations. All right, number 2. Look at the system of equations below. Which method would you use to find its solution? Well, neither of the lines are in slope-intercept form. So let's take out graphing. Furthermore, neither equation is solved for a variable, meaning neither equation has just x or y by itself on one of the sides of the equation. So we're not going to use substitution because we don't have a ready-made solution to one of the variables to plug in. So in this case, we're going to use elimination. And another reason elimination is going to be effective in this is because if you look at the y coefficients, 5 and negative 10, if we double 5 and get positive 10, and then add these equations, we'll eliminate or cancel out the y term. So we should use elimination. If we double the first equation, we'll get 10y. We can then add the two equations, cancel out the y terms. That's called elimination, and then solve for x. So down here we're going to work on that solution. So I'm going to double this first equation and get 8x plus 10y equals 60. And then 9x minus 10y equals 110 is the second equation. Let's add those up. We get 17x equals 170 because the y terms get eliminated. Divide by 17 and we find x equals 10. So we're halfway there. Now we need to take this x equals 10 and plug it into either of these equations up here and solve for y. Well, this first equation looks easier, so let's plug it into that one. 4 times 10 plus 5y equals 30. 40 plus 5y equals 30. Subtract 40 from both sides and we get 5y equals negative 10. Y equals negative 2. So our solution is going to be 10, negative 2. All right, our final example, problem 3. Look at the systems of equations below. Which method would you use to find its solution? Well, we have one of the equations in slope-intercept form. So actually, we can take a look at how we would solve this with graphing. But if you notice, this second equation is solved for y. We have y all by itself on the left-hand side. So we're going to use substitution. The second equation is solved for y. We should use substitution and plug negative 2x minus 3 into y in the first equation, then solve for x. So let's do that down here. We're going to take this negative 2x minus 3 and we're going to plug it into y in the first equation. So I'm going to rewrite this first equation, but instead of y, I'm going to put parentheses negative 2x minus 3. And then I'm going to distribute this negative 3. And that's going to get me 2x plus 6x, right? Negative 3 times negative 2 is positive 6. Then negative 3 times negative 3 is positive 9. So I distributed. Now we're going to combine these like terms. 2x plus 6x, that's 8x. 8x plus 9 is negative 23. Subtract 9 from both sides, 8x equals negative 32. Divide by 8, x equals negative 4. So that's our half of our solution. Now we're going to take this negative 4 and let's plug it in to this equation right here. Y equals negative 2x minus 3. And we just found that x equals negative 4. So we plug that into x. And negative 2 times negative 4 is 8. 8 minus 3 is 5. So our solution is negative 4 comma 5. X equals negative 4, y equals 5. Now let's actually graph this out and prove that if we graph these two lines, they intersect at negative 4 comma 5. So I'll copy these down here. This one's already in slope-intercept form. So let's take this first equation and manipulate it to get it in slope-intercept form. Meaning we want to get y all by itself. Well, let's subtract 2x from both sides. And we're left with negative 3y equals negative 2x minus 23. And now let's divide everything by negative 3. Y equals 2/3 x plus 23/3. I'm going to just leave that as an improper fraction for now. So y equals 2/3 x plus 23/3. Let's graph that in Desmos. 2/3 x plus 23/3. And our other equation was y equals negative 2x minus 3. Now, even though that first equation is kind of funky looking, check it out. These two lines cross at negative 4 comma 5, which is our solution to this system of equations.